A red light of wavelength 670 nanometer produces a photoelectron from a certain metal which requires a stopping potential of 0.5 volt. What is the work function and threshold wavelength of the metal? Let's look at the problem here. Suppose there is a metal and this radiation of 670 nanometer removes an electron. This electron's stopping potential equal to 0.5 volt. Then what is the work function of the metal? This is a question. So what is the work function and the threshold wavelength of the metal? Very simple question. If you know the same shortcut, energy equal to 1242 electron volt nanometer by lambda, or lambda equal to 1242 electron volt nanometer by energy. If energy equal to work function, this lambda becomes lambda naught, which is threshold wavelength. And you see, if there is an energy of this much energy falls on this, it gives an electron of stopping potential 0.5 volt. If electron is accelerated by 1 volt, it gains an energy of 1 electron volt. So if the stopping potential 0.5 volt means energy of the electron is 0.5 electron volt. So you know the energy of the electron, which is 0.5 electron volt. You don't know the work function, but you know the wavelength of this. Let us try to find the energy of this wavelength. What is its energy? What is its energy? Using this formula, energy equal to 1242 electron volt nanometer by lambda. Lambda is 670 nanometer. See, in nanometer only you are supposed to substitute. So they have given in nanometer itself. When you cancel this, 1242 by 670 into electron volt. So 1242 by 670 will give you roughly 1.854 electron volt. So it's basically, I'll just write this in terms of energy. Energy of this radiation is 1.854 electron volt. So photoelectron coming out with energy 0.5 electron volt. So we don't know the work function. So this is the incident energy. This is the kinetic energy of photoelectron. What is the photoelectric effect equation? Incident energy minus work function equal to kinetic energy of the photoelectron. Incident energy is 1.854 electron volt minus work function we don't know. Kinetic energy is 0.5 electron volt. So W is equal to 1.854 electron volt minus 0.5 electron volt. That gives us 1.354 electron volt. So that you now know the work function of the metal. Once you know the work function, we just need to find what this threshold wavelength. Again, if you know this is actually work function, threshold wavelength formula, lambda is equal to 1242 electron volt nanometer by energy. If energy is work function, wavelength is equal to threshold wavelength. So it is 1242 electron volt nanometer by work function. They have given it to be 1.354 electron volt. So electron volt will be cancelled. 1242 by 1.354, which is roughly 917.3 nanometer, or this can be written as 9173 angstrom, which is greater than the wavelength of red radiation. That is why it falls in infrared radiation.